Okay, let's talk about square roots. So what is square root? This symbol, this little symbol, this is called a radical sign, or square root, or simply just root. The square root of something, some expression, is another expression whose square is the expression under the symbol, under the radical symbol. So if you look at this example, square root of 9, what is square root of 9? So what is this? Well, which number squared equals 9? Well, 3 squared is 9. So then this is square root of 9 is 3. What about, for example, square root of 16? 16 is 4 squared. Right? 16 is 4 squared, so square root of 16 is 4. So in the second example, we have a fraction. So what is square root of 4 over 25? We can just take a square root of 4 and take a square root of 25. And square root of 4 is 2 because 2 squared is 4. And square root of 25 is 5 because 5 squared equals 25. So let's check the answer. If you take square of 2/5, this is 2 over 5 times 2 over 5. And it's the same as 2 squared over 5 squared, which is 4 over 25. So when you take a square of a fraction, you basically take squares of numerators and denominators separately. So that's it. That's why we take a square root of a fraction by computing square root of numerator and denominator separately. Okay, let's look at the next example. Okay, square root of x squared. So what is square root of x squared? You're going to assume x is a positive numbers for simplicity. Suppose. So what is this? What is this? What expression squared is x squared? Well, obviously x squared is x squared, so this is going to be x. So here we have a nice simple formula. Square root of any positive number squared is equal to the number x itself. So it looks like the radical sign and the squaring operation cancel each other out. Okay? And let's look at the next example. Square root of 9 squared. So what is square root of 9 squared? Well, this is square root of 9, as you know, this is 3. And 3 squared equals 9. So basically we get the number inside the radical sign as the answer. So again, it looks like the squaring operation, again, this cancels the radical sign. So here is another nice formula. If you have a square root of x squared, this is also equal to x. So if you write these all together, there I gave you two formulas. They are all equal to each other. Square root of x squared, whether that square is inside the radical or outside the radical, it doesn't matter. That square cancels the radical sign, it gives you x back. For example, here's another example. What is square root of 3 squared? Well, this equals 3. What is square root of 5 squared? That is 5. Okay? Okay, here is the next example. Square root of 12. So, in fact, 12 is not a perfect square. Well, 9 is 3 squared. This is perfect square. 16 is a perfect square. This is 4 squared. But 12, there is no integer between 3 and 4. No whole number squared equals 12. So which number squared equals 12? Well, but it must be somewhere between 3 and 4. So this must be 3 point something. But we don't want a decimal number. when you want to simplify a radical, it means not to find the decimal approximation, but it means to pull out all possible squared factors out of the radical sign. So to simplify this expression, this number, we're going to factor the number 12. Factor the number 12 as a product of 3 and 4. And then we can write this as square root of 3.4, 3 times 4. And then we can break this out, square root of 3 times square root of 4. Okay? So this is another nice property of square root. And square root of 4 equals 2, so this is 2 times square root of 3. So let me explain why we can break this up, and at the same time we're going to verify the solution. So 2 square root of 3 squared, is this really equal to 12? Well, this is 2 square root of 3 times the same number. And if you collect 2 and 2, that's 2 squared, and square root of 3, 2 of them, this is root 3 squared. And this is 4 times 3, and that's 12. So see here, when you take square of a product of two numbers, it basically distributes, and we're taking square of each factor, and then we multiply them. And square root of kind of reverse operation. So when you take square root of the product of two factors, you can take square root of each factor and multiply them. So here is the formula. Square root of a times b, you can break this up, and then we can compute square root of smaller numbers. Okay, so here is the next example. Can you simplify this expression? Can you break up these two terms? If you can do that, square root of x squared is x, and root 4 equals 2. Simplify, right? But don't do this. You can't do this. You can't do this. Wrong. This is wrong because in general, if you have two terms, you can break up factors. You can break up factors. Just I explained this just a moment ago. But you can't don't do this. Don't break up terms. So you can't do this in general. And here is why you can't do this. So, for example, square root of 4. This equals 2, right? But 4 is also 1 plus 1 plus 1 plus 1. And if you could break these all up, if you could break up terms, this is going to give you, square root of 1 is 1 because 1 squared is 1. Okay, so this is 1 plus 1 plus 1 plus 1, that's 4. So is 2 equal to 4? No, 2 is not 4. The bottom line is you cannot break up terms. You can break up only factors. Okay, here is one last example. We want to simplify this radical expression. I just told you that you cannot break up terms. So if you want to simplify this, factor first. So 64 is a common factor, and you see x to the 6th, that is another common factor. So pull them out, what is left? Well, we are left with x squared plus 1. Okay? Now we can break up everything. Square root of 64, square root of x to the 6th, and square root of x squared plus 1. 64 is 8 squared, so this is 8. And which expression squared equals x to the 6th? Well, x cubed squared equals x to the 6th, because x cubed is 3 factors of x, and if you multiply another 3 factors of x, the total number of x's is 6. So that's x cubed, 8x cubed times, now the last radical expression, you cannot simplify this any further. So there you go, the answer is 8x cubed radical x squared plus 1.